Learning objectives. At the end of this topic, you will be able to understand Euclid's division lemma, calculate HCF of the given number using Euclid's lemma. Let's take an example to start with Euclid's division lemma. Imagine it's your birthday and you got 13 chocolates which have to be distributed among your 4 friends. In this case, we refer to 13 as the divisor, to 4 as the dividend, and the number of times that 4 can be divided among 13 as the quotient. When the divisor cannot be distributed equally to the dividend, the leftover balance is referred to as the remainder. So, by dividing 13 by 4, we get 3 as the quotient and 1 as the remainder. Can we frame a relation between the divisor, dividend, quotient, and remainder? Yes, we can note that dividend is equal to divisor into quotient plus remainder. Taking this as base, we can frame Euclid's division lemma as: given positive integers a and b, there exists unique integers q and r, satisfying a is equal to bq plus r, 0 less than equal to r less than equal to b. Euclid's division algorithm is based on this lemma. An algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. An example algorithm that would be used to solve the problem of why a lamp doesn't turn on. There are 3 possible fixes that are determined by going through 3 possible problem steps. The word algorithm comes from the name of the 9th century Persian mathematician Al-Khwarizmi. In fact, even the word algebra is derived from a book he wrote called Hisab al-Jabr wal-Muqabla. A lemma is a proven statement used for proving another statement. Finding HCF of the given number using Euclid's lemma. Euclid's division algorithm is a technique to compute the highest common factor, HCF, of 2 given positive integers. We've learned from the previous classes that the HCF of 2 positive integers a and b is the largest positive integer d that divides both a and b. So, after going through the example, let's state Euclid's division algorithm. To obtain the HCF of 2 positive integers, say c and d, with c greater than d, the following steps need to be followed. Step 1. Apply Euclid's division lemma to c and d. So we find whole numbers q and r such that c is equal to dq plus r, 0 less than equal to r less than d. Step 2. If r is equal to 0, d is the HCF of c and d. If r is not equal to 0, apply the division lemma to d and r. Step 3. Continue the process till the remainder is 0. The divisor at this stage will be required HCF. Let's work out some examples on Euclid's division algorithm to find HCF of 2 numbers. Use Euclid's algorithm to find the HCF of 4052 and 12576. Step 1. Since 12576 greater than 4052, we apply the division lemma. Step 2. Since the remainder 420 is not equal to 0, we apply the division lemma to 4052 and 420 to get 4052 is equal to 420 into 9 plus 272. Step 3. We consider the new divisor 420 and the new remainder 272 and apply the division lemma to get 420 is equal to 272 into 1 plus 148. We consider the new divisor 272 and the new remainder 148 and apply the division lemma to get 272 is equal to 148 into 1 plus 124. We consider the new divisor 148 and the new remainder 124 and apply the division lemma to get 148 is equal to 124 into 1 plus 24. We consider the new divisor 124 and the new remainder 24, and apply the division lemma to get 124 is equal to 24 into 5 plus 4. We consider the new divisor 24 and the new remainder 4 and apply the division lemma to get 24 is equal to 4 into 6 plus 0. The remainder has now become 0, so our procedure stops. Since the divisor at this stage is 4, the HCF of 12,576 and 4,052 is 4. Notice that 4 is equal to HCF of 24, 4 is equal to HCF of 124, 24 is equal to HCF of 148, 124 is equal to HCF of 272, 148 is equal to HCF of 420, 272 is equal to HCF of 4052, 420 is equal to HCF of 12,576, 4,052. Use Euclid's algorithm to find the HCF of 420 and 130. Solution. Step 1. Since 420 is greater than 130, we apply the division lemma to 420 and 130 to get 420 is equal to 130 into 3 plus 30. Step 2. Since 30 is not equal to 0, we apply the division lemma to 130 and 30. We get 130 is equal to 30 into 4 plus 10. Step 3. Since 10 is not equal to 0, we apply the division lemma to 30 and 10 to get 30 is equal to 10 into 3 plus 0. The remainder has now become 0, so our procedure stops. Since the divisor at this step is 10, the HCF of 420 and 130 is 10. Let's move to the second example. Explain that any positive odd integer is of the form 4q plus 3 or 4q plus 1, where q is an integer. Step 1. Let's start with taking a, where a is a positive odd integer. We apply the division algorithm with a and b equal to 4. Step 2. Since 0 less than equal to r less than 4, the possible remainders are 0, 1, 2, and 3. That is, a can be 4q or 4q plus 1, or 4q plus 2, or 4q plus 3, where q is the quotient. Step 3. However, since a is odd, a cannot be 4q or 4q plus 2, since they're both divisible by 2. Therefore, any odd integer is of the form 4q plus 1 or 4q plus 3. Let's move to the third example. Show that every positive even integer is of the form 2q, and that every positive odd integer is of the form 2q plus 1, where q is some integer. Step 1. Let a be any positive integer and b equal to 2. Step 2. Then by Euclid's algorithm, a is equal to 2q plus r for some integer q greater than equal to 0, and r is equal to 0 or r is equal to 1, because 0 less than equal to r is less than 2. So, a is equal to 2q or 2q plus 1. Step 3. If a is of the form 2q, then a is an even integer. Also, a positive integer can be either even or odd. Therefore, any positive odd integer is of the form 2q plus 1. Summary. Let's summarize the topic. Euclid's division lemma states that given positive integers a and b, there exists unique integers q and r satisfying a is equal to bq plus r, 0 less than equal to r less than b. This result was perhaps known for a long time, but was first recorded in Book 7 of Euclid's Elements. Euclid's division algorithm is a technique to compute the highest common factor, HCF of two given positive integers. HCF of two positive integers a and b is the largest positive integer d that divides both a and b.